All right, so now we're going to look at some examples for applying our equations to real-world application problems. So looking at our first one, it says a parking garage charges a $3 flat fee and $1.50 per hour. You have $12 to spend for parking. Write and solve an equation to find the number of hours that you can park. All right, so everybody using their little bookmarks, I want everybody to go through and circle all the numbers. Okay, so I see $3.50 and 12. So those are going to be our important numbers that we're going to be using when working through this problem. So now that we've circled the numbers, we're going to underline our keywords. So remember about all those words that we wrote down to represent all of our mathematical operations. So we said our first word that we're looking at here is going to be and. Remember we said and means anytime we have a plus. Okay, that always is going to be an addition. So and is going to be addition. So we had this 3 and $1.50, so $1.50. We said per means multiplication, so per hour. So we're going to say per hour. Okay, so per is also going to be a keyword. Okay, and that means multiplication. So I'm going to put a dot for multiplication. So now we're going to box in the question. Okay, so it says write and solve an equation to find the number of hours that you can park. So that is what we're looking for. That's the question. How many hours can I park? So the number of hours you can park. Well, at this point, we basically have our problem set up. So with that, we have to box in box in the question, and then we write our let statement. Remember, the question is the let statement. Remember, x is always what we're trying to find. So we're going to let x equal. Well, what was in the box? The number of hours that you can park. So the number of hours I can park. Okay, so we've got that part done. Next, okay, we need to think, is there anything we can eliminate? We've used almost everything in our description, so we're good. So now we need to write an equation to represent the situation. Okay, so we're just going to read this from left to right. The first thing says we have a flat fee. Okay, so that's this right here. So we know we're going to have that $3, so 3. And, so plus $1.50 per hour. Well, we just said x was the number of hours. So anytime we see hour, we know that's going to be an x. So $1.50 per, so times x. So 1.5 times x, or x. And I know I have $12 to spend, so that's going to be my total. So I'm going to set the equal to 12. Really, once you have your numbers circled and your keywords underlined, that's basically your entire equation. That's really all you have to do. So this is my equation to represent the situation. So now we're at the very last letter, right at the S. We need to solve the equation. So I'm going to subtract 3 from both sides. That'll go away. I'll have 1.5x is equal to 9. I'm going to divide out the 1.5. Those will cancel out. So I'll have x is equal to 9 divided by 1.5 is going to give me 6. All right. So we have 6 right here. And now we need to think, does that make sense? Okay. Does that answer actually make sense? Yeah, it does. It makes sense that I could park for 6 hours. If I had gotten a negative number, that would not have made sense. I can't park for a negative amount of time. Okay, so we can go ahead and write our sentence. Okay, so I can park for 6 hours. Alrighty, looking at the next one. So it says we have a 12-inch candle and an 18-inch candle are lit at 6 p.m. The 12-inch candle burns 1 inch every hour. The 18-inch candle burns 2 inches every hour. How many hours will the two candles be the same height? Okay, so looking at this, okay, the first thing we need to do is to circle our numbers. So I have a 12-inch candle. Just because it's not written as a number doesn't mean 12 isn't a number. So we have a 12-inch candle and an 18-inch candle. 6 is definitely a number, but we're really focusing on the inches here. Okay, so I don't really think that's necessary. So we're going to skip that for now. We know that the 12-inch candle burns 1 inch every hour. And the 18-inch candle burns 2 inches every hour. How many hours will the two candles be the same height? So those are our important numbers. The next task that we have is to underline our keywords. So here's and. So we have an and. The 12-inch candle burns 1 inch every hour. Every is going to be multiplication. The 18-inch candle burns 2 inches every hour. Now, the other keyword that we have in here is the word burns. If a candle is burning, is it getting taller or is it getting shorter? Well, it's getting shorter, so it's going to be losing some of its height. Okay, so that's going to be a subtracting. So we're going to say burns is subtracting. All right, so there are our keywords. Now we're going to box in the question. Okay, so it says, after how many hours will the two candles be the same height? So that's my question. So once we've boxed in our question, then we can write our let statement. So let x. Okay, well, what was the question? After how many hours? So that's what we're trying to find. So we're going to let x equal the number of hours. All right, so let's go ahead and write our equation. We're going to start with the 12-inch candle. We're comparing two things. So this is where we're going to have to set two things equal to each other. We're comparing the two things, so we're going to set them equal to each other. So first, we're going to compare the 12-inch candle. So it says the 12-inch candle, okay, so we're going to start at 12, burns, okay, so it's burning, so we're subtracting, it loses 1 inch every hour. Okay, so 1 every hour. Well, we just said hours were our x's. Okay, so we're going to have 1x is equal to the 18-inch candle, and it burns, so it loses, subtracts 2 inches every hour. Well, we said hour was x's, and every is multiplication, so 2x. All right. So now we just need to solve this like normal. So I'm going to add 2x to both sides. That cancels out. So I'll have 12. Negative 1 plus 2 gives me plus 1x equals 18. Subtract the 12. I said 18 and wrote 12. My bad, guys. So we subtract the 12. Those cancel out, and I'll get 1x is equal to 18 minus 12 gives me 6. Once again, we need to stop and think, does this actually make sense? And it does, because it's a positive number, so we can have positive time. Okay, so the candles burn for 6 hours. Alrighty. Alright, so we're going to do one more. So if you want to flip the page over, we're going to do one more together. Okay, and this one says, your little brother has decided he wants a rectangular sandbox in the backyard. You decide to be nice and build it for him. You know you want the length to be 4 feet longer than the width. Okay, so I want everybody to go ahead and draw a picture and set up the perimeter for me. All right, so I hope you took the time to set up your picture. Okay, so we know it's a rectangle. I didn't tell you what the width was, so we should have all labeled it X. And I want the length to be 4 feet longer. Well, remember, that means we're going to be adding. So it's going to be X plus 4. Well, that didn't show up at all, did it? X plus 4. All right, so to find the perimeter, this is where we got to add up all of our sides. Okay, so I had 1, 2, 3, 4 x's, so 4x. And then 4 plus 4 gave me plus 8. So that describes the perimeter of my pin. Okay, so now I have to do something a little extra with it. I know I have 26 feet of boards to make the sides. So now I can actually figure out how long is that width going to be. So I know I have 26 feet for the sides. So we're going to take this perimeter, our 4x plus 8, and we're going to set the equal to 26. Because now I can actually find what the length and the width need to be. I don't have to guess anymore. So this is just a two-step equation. So we're going to solve this. So we're going to subtract 8. So we'll get 4x is equal to 26 minus 8 gives me 18. Subtract or divide out the 4. Okay, and we're going to get a decimal, but remember, you can have like half a foot. Okay, so 18 divided by 4 is going to give me 4.5. So x is going to equal 4.5. All right, so that is the width of my sandbox, because since I said this is x, right? Okay, and I said the width up here was x. So I know that the width has to be 4.5 feet. So we're all going to label that. The width is 4.5 feet. Oops, not 4.2. Now the length, on the other hand, we said the length had to be 4 feet longer. Okay, so if we look at this, remember we said 4 feet longer, 4 feet longer. So what we're going to do is we're just going to add 4 to our width. Well, 4.5 plus 4 is going to give me 8.5. So the width has to be 8.5 feet. All right, guys, if you have any questions about that one, let me know. Remember, you also have your notes in your notebook. Okay, but if not, you can move on to your next assignment.